can function. Can evaluates an expression and returns a boolean based on whether that expression produced a result without error. The mechanism is error probing, not value replacement. The outcome is that Terraform can convert a dynamic evaluation failure into true or false. This matters when the question is not what a fallback value should I use, but did this expression succeed at all? That makes can a Boolean gate for validation logic, not a general recovery pattern. Can only catches dynamic errors that arise while Terraform evaluates data whose final shape is not safely known in advance. The mechanism is runtime style expression checking inside Terraform's evaluation model. That outcome is that missing map keys, missing object attributes, or format checks can be turned into booleans. Can does not catch expressions that Terraform can prove are invalid before dynamic evaluation even begins. If the reference itself is malformed or points to an undeclared top-level object, Terraform fails immediately instead of returning false. That means can is not a shield around bad syntax or broken references. The primary intended use of can is variable validation. The mechanism is that Terraform evaluates a function that may fail and converts that success or failure into the condition field of a validation block. The outcome is that invalid input is rejected before it can flow deeper into resources, locals, or module logic. This keeps the failure close to the input boundary. That improves operator feedback because the error explains what the caller must fix, rather than surfacing later as a secondary failure inside resource arguments. HashiCorp recommends try for most error handling cases outside simple validation because try returns a usable fallback value, while can only returns a boolean. The mechanism is different. Can answers, did this expression succeed? Try answers, give me the first expression that succeeds. The outcome is that try fits data normalization, optional attributes, and defaulting patterns more directly. Using can where try should be used often creates two-step logic that is harder to read and easier to miswire. A Boolean test plus a second branch is more moving parts than a direct fallback expression. A submarine panel can show a normal indicator while the real fault is upstream in the sensing path. The mechanism is false confidence from a past check that measured the wrong thing. The outcome is delayed detection. Can creates the same risk when engineers use it to silence structure problems instead of validating input contracts. A false result can look controlled even when the real issue is schema drift, a bad module interface, or an unexpected object shape. That is why can belongs near input validation, where the Boolean has operational meaning. Used deeper in resource logic, it can turn a broken assumption into a quiet branch instead of a clear failure.